Okay, guys, we're going to get started with our notes, starting with this new unit dealing with right triangles and trigonometry. And the first section of this unit is the Pythagorean Theorem and its converse. So the first theorem that we're going to look at is the Pythagorean Theorem. You should be familiar with it because you've gone over it in middle school. And basically what that theorem states is if, and let's zoom in a little. Just making sure I have everything covered. Okay, if a triangle is a right triangle, then the sum of the squares of the lengths of the legs, and we're missing this little piece. It should be legs, so let's write that up here. Sorry about that. Is equal to the square of the length of the hypotenuse. All right, so we have our if statement, if, and we have our triangle. We're going to label this A, B, C. And so with a right triangle dealing with hypotenuse and leg, our hypotenuse is typically it's the longest side. So if we have this triangle, and it's a right triangle, so let me put this in here first. So if triangle ABC is a right triangle, then we know from the right angle directly across is the hypotenuse. So this is my hypotenuse. And the two remaining sides are the legs. So this is from B to C. This is going to be my leg 1, which I'm highlighting in pink. So this is going to be leg 1. And from A to C, this is going to be leg 2. So if we know that this is a right triangle, then we'll write it down here. Then we know that the leg 1, let's find my pink pen, leg 1 squared plus leg 2 squared is going to be equal to the hypotenuse squared. Now I know you're used to seeing A, B, and C, and the A and B are very interchangeable. Like this could be my A, this could be my B, and our hypotenuse is always directly across, but it's good for you to know that, hey, we have a hypotenuse, and if it's a right triangle, the other two sides are called legs. So I'm saying this is leg 1, and this is leg 2. So let's get used to that form of the formula, because A, B, and C are very interchangeable, all right? So let us, and I'm going to zoom in a little bit more, let us get to the second theorem. So this is just the converse, and if you recall with the converse, we're just going to interchange the if and the then statement. So we're going to start off with our then, and then our if is going to be our conclusion, all right? So for this one, moving this over some. So for this one, if the sum of the squares, of the lengths of two sides of a triangle is equal to the, now we have some mistakes going on here, so we're going to cross this out, okay, cross that out, and this is going to be square. We're going to cross out of the length. We just made a mistake. Scratch it out. So of the length, it should be square of the third side, then the triangle is a right triangle, okay? So make sure you cross out these pieces I told you to, the first of the and the of the length, okay? So we are gonna have our if statement. If I still have my triangle, this is A, B, C. So basically, I'm not gonna put in the right angle because right now I'm trying to show you that it is a right triangle. So we're going to have from A to B, this is my hypotenuse, which I have highlighted in green. This piece is one of my legs, leg 1. And this is my second leg, leg 2. So basically what it says, if the sum of the squares of the lengths of the two sides of the triangle is equal to the square of the third side, then the triangle is a right triangle. So basically, if I take my two sides, I'm going to use my legs. So if BC squared plus AC use the right color, sorry. Plus AC squared is equal to my hypotenuse, which is AB, and I'm squaring it. So if this is true, then I can say that triangle ABC is a right triangle. Okay? So if I can say this is true, then I can draw in my little box to show that, hey, this is a right triangle. All right? So those are our first two theorems. Let us flip this over so that we can do the next two. Oops, sorry for that little adjustment. Okay, so now we're going to be looking at the obtuse triangle theorem. So the obtuse triangle theorem, basically what this is stating is, let's move this over. If the square, and I hope this doesn't run out of ink, looks like it might. If the square of the length of the longest side of, and let me zoom out a little so you can see all of it, of the longest side of a triangle is greater than the sum of the squares of the lengths of the other two sides, then the triangle is obtuse. So what this is saying, and let me zoom in a little, just a little, all right? So what this is saying, if I have the square of the length of the longest side of a triangle and it's greater than the sum of the squares of the length of the other two sides, then the triangle is obtuse. So what we need to focus on is going to be if it's greater than, I'm going to highlight the greater than piece. If the length of the side, the square of the length of the side of a triangle is greater than the sum of the other two sides, then this is going to be an obtuse triangle. All right? So we have our triangle. We have our triangle ABC. So basically, from C to B, I'm going to use orange. And so since this side is directly across from A, I'm going to call this side A. For BC, or actually from BA, I'm going to do that in blue. And since C is directly across from that, I'm going to call this side C. And you know, I'm going to use pink first, C to A. And since B is directly across from that, I'm going to call this B. So basically what our if statement is saying is it's the square of the longest side. So my longest side B. So I'm going to have B. And I square it. If it's greater than the sum of my two smaller sides, which are A, and that's going to be squared, plus my C, which is squared, then I know triangle, I'm going to do it in a different color. I guess I'll use this dark blue. Triangle ABC is obtuse. Okay? So my longest side, if I squared and it's greater than the two shorter sides, then my triangle is obtuse. All right? So let's look at our last theorem. And this theorem is the acute triangle theorem. So basically, it's going to probably be the opposite. Instead of B, the longest side being greater, it's going to be if it's smaller. All right? So for this one, if, and I'm trying to pick out a color that's going to work for me. I think I'm going to just use black to write. So basically, if the square of the length of the longest, make sure you can see that, bring that over, side of a triangle is less than the sum of the squares of the lengths of the other two sides, then the triangle is acute. All right, so again, we need to focus on, in this case, we're looking at something that's going to be, it has to be less than. If it's less than, then we know this triangle is going to be acute. All right, so we have our triangle ABC, and I'm going to basically use the same colors. So from C to A, that's going to be pink. And since B is directly across from that, this side is going to be B. B to A is going to be blue. And since C is directly across from that, that's going to be my C. And from B to C, that's going to be orange. Since A is directly across from that, this is going to be my side A. All right? So zoom in a little so you can see. If I know that my long side here is C, okay? So if C squared, sorry, all these pins, if C squared is less than A squared, and actually I should have done this squared in black, plus B squared, then I know my triangle triangle ABC is acute. All right, so if we zoom out so you guys can see a little better, these are our theorems, and we're going to come back and get the notes. We've done the notes, I mean the examples. All right.